Is it really necessary? That's the question. To know in-depth knowledge. So far you have I've asked so many questions, and there are a lot of technologies where it is important because you've been using your machine since a very long time. So when you look at the anesthesia machine functions and hazards, the functions are actually very clear. Ventilation and deliver gases and anesthetic agents, and the problems if it is not performing appropriately are the hypoxia, hypercarbia, barotrauma, volume trauma. Patient can have awareness. But what is the real magnitude of this issue? This was addressed first time by Kaplan when he published in 1997 adverse anesthesia outcome arising out from the gas anesthesia machine. They are nearly 2%, which was significant. More important thing out of this was whenever there was a complication, majority of them, 76%, had death or permanent brain damage. So morbidity and mortality is very severe if you are actually, if you don't use it well, if there is a problem. And 70% of them were deemed preventable. So it is very, very important that we have to look at this thing. And this led to changes in anesthesia machine. So we started from the simple boils apparatus or simple boils machine to these workstations were designed. In fact, their obsolescence guidelines were published in 2004, where lack of certain features, presence of unacceptable features, or lack of certain desirable feature were considered, and on that basis machines were made obsolete and some new features were added like hypoxia guard, positioning oxygen flow meter, safety system, alarm system, mandatory pre-use checklist, precise delivery, so much. There are so many changes were addressed in your anesthesia workstation. This really has this made a difference. So a recent close claim analysis update in 2013 very clearly identified that gas delivery claim were now decreased from 2% to 1%. Outcomes were less severe, more of a barotrauma, which was easily manageable. But in spite of that, majority of them, 85% of claim involved provider error. So main problem is probably users' ignorance or lack of training in use of newer technology, and even best of the anesthesia machine you have, it can still harm your patient if you are not aware about technological advancement and its limitation. So prime responsibility to understand function of anesthetic equipment and to check it before it's used, and you must not use equipment unless you have been trained to use it and competent to do so. And looking at the questions which I asked you, majority of you are not aware about this technical part of your anesthesia machine. These are the standard technologies which are used in your machine. Takes us to a question, are we really competent enough to use this workstation? Our anesthesia workstations are supposed to be WYS, WYG. That means what you said, what you get. So when you decide to give some, say 400 or 500 ml of tidal volume, is your anesthesia machine delivering the same? Is it giving accurately what you have said? That is an important question. Now, I'm just showing you a video of one anesthesia machine where right now I have set 350 tidal volume and the flow rate is 1 liter, 500 ml, 500. Now what I'll do is, I'll try to increase flow rate. I'll increase it to say total 5 liters. Internet connection. Are we good to go? Is it okay?
Yes, Dr. Amisha. So Dr. Diwan has just joined the session. Please continue.
Yeah. Welcome, Dr. Diwan sir. Good evening. Okay. So we'll continue. So what I was showing here.
Good evening. Good evening.
With 1 liter of flow, the tidal volume which was set as 350, I have increased the flow. I have increased flow to 5 liter. And what is the situation? Just observe the tidal volume. This is the tidal volume, 450 ml. So with 5 liter flow, suddenly tidal volume has jumped to 470 ml instead of which was set as 350 ml. Now why this is happening? And imagine this situation, if you are dealing with a pediatric patient at the end of surgery, you just want to flush out the anesthetic agent and you increase flow and tidal volume suddenly jumps. So to understand behind this, the reason behind why our tidal volume changes when you change the flow, we'll have to understand the basic circuit design and flow kinetics. So this is a very simple circuit diagram, which is probably known to everyone. You know what are the components. These are unidirectional valve, expiratory and inspiratory unidirectional valve, soda lime absorber. This is the changeover switch. This is the reservoir bag. This is APL valve, and this is the ventilator. Now, when patient expires, the flow passes through the expiratory unidirectional valve and goes to the reservoir. At same time, the fresh gas flow will also, since the inspiratory valve is closed, fresh gas flow will also go to the reservoir. Now, when patient starts taking breath, that is inspiration, or when you decide to squeeze the bag, the gas which is there in the reservoir bag will pass through soda lime canister, and in the same time, the fresh gas flow which is flowing both of them will join, go to the inspiratory tubing through the inspiratory unidirectional valve and will be going to the patient. If you decide to use ventilator, then during expiration, all gas in many anesthesia machine will go to the bellows. Same time, same situation from the fresh gas flow will also go to bellows. When the ventilator's bellows are squeezed for the tidal volume, let's say we have set 500 ml tidal volume. So 500 ml of air or a gas from the bellows will go to the inspiratory line. Simultaneously, flow from the flow meter will also go to the inspiratory line. Together, it will be delivered to the patient. Patient may have 570 ml. But imagine if you increase flow from 2 liter to 4 liter, more amount of flow is joining in the inspiratory line. And the tidal volume will be 640. So if this is a situation where inspiratory flow is joining with the ventilator flow in the inspiratory line, then the tidal volume may vary if you change the fresh gas flow. Now, how workstation try to avoid this? How they achieve a precise delivery of tidal volume? So the culprit here is this particular point. A mixing of ventilator flow and fresh gas flow is a major reason. So what Draeger company has come out with a solution is called the decoupling valve. So here they have made a one-way valve in this inspiratory line. So when piston is trying to deliver 500 ml tidal volume, this decoupled valve will get closed. So you don't get any fresh gas flow or any flow from the reservoir into the inspiratory line. So in the inspiratory line, because of this decoupled valve, fresh gas flow is not mixing. So whatever is delivered by the ventilator is straight away going to the patient. So if you decide to deliver 500, it will only deliver 500. It will not have any impact because of fresh gas flow changes. Of course, in expiration, when the piston pulls out, the reservoir gas as well as fresh gas flow will go into the piston. So there is no FGF mixing in inspiratory line during inspiration. Now this is the patented technology of the Draeger. Decoupling mechanism is a patented technology. No one else can use it. So what other anesthesia machines have done? Now this is already drill which we know that with 4 liter the tidal volume jumps. Now what other companies have done is they have added a flow sensor in that inspiratory line to identify what is the flow. So now there is a flow sensor in inspiratory line which will identify the amount of flow. Now that machine also, we have set 500 and the 640 has been delivered. So machine knows extra 140 is given. So in next breath or next breaths, the bellows will deliver slightly less. It will deliver only 360 ml. So now the flow will be, the end result would be 500, but bellows are pushing less and more amount of flow. So as soon as you change it, in next few breaths, things will change. This is called fresh gas compensation. So there are two technologies. One is called decoupling mechanism. Second is called fresh gas compensation. So precise delivery of tidal volume by majority of the anesthesia machines are done by two techniques. One is called Freshness Decoupling, which is a piston technology. Now here the compensation is absolute. There is no mixing of fresh gas flow with the inspired flow. While in case of electronic fresh gas compensation, which is routinely there with all bellows technology, it is slightly relative compensation in many machines because the message is given to the machine ventilator, and the ventilator will act in next few breaths. So 1 breath, 2 breaths, or maybe 6 breaths, up to 6 breaths it can take to compensate for the excess of fresh gas flow. So it is a relative compensation. Though some new machines have sensors placed in inspiratory line, and also fresh gas flow is also when it is digitalized, they'll know little early. But still, probably a breath will always be there where you have extra amount of idle volume. So because of this decoupling, what is the behavior of the circuit? So here we already see that this is the ventilator. Reservoir bag gets flow during inspiration and expiration both. And when this decoupling valve is closed, the fresh gas flow as well as expired flow comes to the reservoir. So reservoir bag is a decoupled compartment, and that is the reservoir of your entire system. And you see a slightly different behavior. Now we are always used to a situation where when you squeeze the bag, inspiration occurs. So in inspiration, bag is collapsing, and in expiration, bag is inflating. That is our routine understanding. But when you see these Draeger machines with decoupled technology, the bag inflation is opposite. During inspiration, because of decoupling valve, the bag gets expanded and it gets collapsed during expiration. So it is opposite to your conventional thinking. And if there is a leak or if there is inadequate flow into your system, the bag will get deflated, and probably you will receive a message also that your insufficient flow is there. So gas volume deficiency is identified by deflated bag plus alarm. Of course, there is a minor issue of here is that every time anesthetic gas comes to the reservoir, mixes with the expiratory gas, and then it is delivered. So minuscule reduction or delay in the delivery of anesthetic agent can occur, but it can be easily compensated. So anesthesia agent mixes with expired gas before delivery, so there could be slight delay. Now fresh gas compensation which is there with most of the bellows machine. So here, when you switch over to the ventilator, you must have seen reservoir bag and APL valve, because they are cut off from the system, have no rule. You squeeze that bag, nothing will happen. It will just take out the gases from your APL valve. Nothing else will happen. So what is the reservoir for the system? So bellows are the reservoir for the system. So if there is insufficient flow or if there is leak, you will see bellows not achieving the full height. Bellow will continue to go down from a not so peak height. It will go down from a lower position. And also, of course, it will give you alarm. Here, a minor advantage, FG fresh gas flow is directly added to the inspired gas. So your reflection of changes in the inspired setting is slightly faster compared to the other technique. Now let us take this scenario that we can press the oxygen flush. Let's see whether we should flush the oxygen if there is a gas volume deficiency. So this is again a Draeger circuit with decoupled valve. If I am pressing the flush, what will happen? Now I am pressing the flush. What will happen? If you press the flush, during inspiration, nothing is going to the ventilator. Ventilator will continue to deliver its own 500 tidal volume. The extra gas will go to the reservoir only. Nothing will go to the ventilator. So patient will not have any change in the delivery of tidal volume because nothing is missing in the inspiration. The only problem would be that it bypasses your inhalation anesthetic. It will bypass your vaporizer and it will directly go to the reservoir. Now let's see what will happen with the bellows circuit, where fresh gas compensation is a technology. Now here, my bellows are going down and I want to use flush. If I use flush, I don't want to use flush, but if I use flush, what will happen? It will deliver almost another, when you press flush, the flow is almost 35 to 40 liter per minute, and within that 2 seconds, probably what will deliver is 1000 ml. Now that will go to one reservoir, but also will directly go to the inspiratory line, because there is mixing of fresh gas flow into the inspiratory line. So it is possible that your patient for that breath is going to receive almost 1.5 liter, 1 liter, 1200 ml. So very large amount of flow is delivered to the patient, which can cause barotrauma as well as volume trauma. Fortunately, majority of the machine will prevent barotrauma by keeping a safety limit of, there is a safety upper limit of 40 centimeter of H2 on all anesthesia machine. Beyond that, it will not deliver tidal wave. But imagine that is happening to a pediatric patient. Imagine that can also cause volume trauma. So can we use flush while patient is connected? Absolutely no. In case of bellows anesthesia machine, it can cause barotrauma, it can cause volume trauma. In case of dragger machine, you can do it without doing any harm to the patient. But again, you have to beware of anesthetic agent dilution. Your patient may develop awareness if you press flush. So essentially, you should never use oxygen flush while patient is being ventilated with endotracheal tube or suprapubic. Now let us go to the next pole. That is my next scenario. In fact, different circuits delivers different tidal volume with same setting. You use the pediatric circuit, and if you decided to deliver 200 ml, or if you use the adult circuit and you decided to deliver 200 ml, it can be different or it can change. The reason is circuit compliance. What is circuit compliance? It is essentially expansibility or compressibility of a circuit with the pressure, and each circuit has a different compliance. When the circuit is expanded with the pressure, it leads to loss of some tidal volume retention, loss of some tidal volume in the circuit. So this is volume which is delivered by the ventilator but does not reach lungs because of expansibility of the circuit. This is called wasted ventilation. Newer anesthesia machine can compensate for this. And each circuit has a different compliance. When the circuit is expanded with the pressure, it leads to loss of some tidal volume retention, loss of some tidal volume in the circuit. So this is volume which is delivered by the ventilator but does not reach lungs because of expansibility of the circuit. This is called wasted ventilation. Newer anesthesia machine can compensate for this. This is called compliance compensation. Here, volume correction by device in order to compensate for elasticity and compressible volume of horses and breathing system. How does it achieve? If you must have seen your anesthesia machine, when you start your anesthesia machine, they'll ask you to do certain tests, and when you perform certain tests, this is the result. So these are the results which you got while you test your machine. They test for circuit compliance and tell you about leak also. Now, how compensation is achieved? Suppose if you have set 500 ml tidal volume, and when you have set 500 ml tidal volume, and if your 100 ml is lost on the way, say your 100 ml of gases are lost on the way, so your end result would be 400. Machine by pre-testing knows that okay, we are losing 100 ml, so it will deliver 100 ml extra. So it will deliver 600 ml, provided, so that will compensate for the wasted ventilation and patient will get 500 ml. But this is provided you have done leak and compliance test. Now let us look at the situation. This is the result which I showed you. A leak was 83 ml per minute and compliance was ml per centimeter, that was 2.74. So if I am ventilating at the pressure of 15, what is the compliance loss? It is 41 ml and loss plus the leak which is there per minute. So per loss of breath is 48 ml. So every breath there is a loss of 48 ml. Now if in an adult patient it does not give you a big issue. It is only change of 10% which you can compensate. But imagine that is happening with a pediatric patient. You are losing almost 50% of tidal volume. In fact, many of you might have noted that in spite of adequate tidal volume, many times your ETCO2 remains on the higher side in a pediatric patient if you have not done this compensation. So believe me, it is always proper to check for leak and compensation once you change the circuit. For adult patient or for a pediatric patient, the moment you change circuit, you should again test that circuit for the leak and compliance. So always perform leak and compliance test. In fact, newer advanced anesthesia machine has come out with a large number of tests. It tests for circuit, ventilator, leaking, entire system, electronic sensors, battery, power supply, everything. And our problem is that we tend to bypass it. We are in hurry. We don't know the importance of it and we tend to bypass it. If it is actually giving us leak, we tend to bypass it and start the anesthesia work. It does not give you idea about, it does not compensate for the leak as well as the compliance. Also, you will miss a lot of disconnection, malfunction, or sometimes inadequate agent available. So never bypass your pre-test. As far as possible, always do it. In fact, many machines now have come out with a solution that you cannot bypass it more than 8 times. Like the primers will not allow you to bypass it more than 8 times. Then probably they'll ask you to do the test. Without that, it will not start the machine. In fact, AHEPI has come out that after doing self-test, which is given with the machine, you should again try to do a manual checking even after self-test.